This tutorial is going to cover the export of Paraview results from XT, how to manipulate the results in Paraview, export a file that you can then read into Blender, and do some rendering of images. I've got a simple model here in XT version 4, and I'm showing the mesh here just to highlight that when you do look at results in Paraview, the results are going to be interpolated a bit differently than they are in XT, so areas where the mesh is a lot larger than the adjacent mesh may come through and not give you the results you want. Anyway, so I'm going to proceed anyway, and the first step would be to create a result export. I'm going to choose Paraview, and I typically just choose temperature and velocity. Pick a output directory, and I'm going to export the result. Okay, I've opened Paraview. I'm in version 5.4.1. I'm on Windows 10, and it's worth pointing out something. When I first started using Paraview on Windows 10, the graphics in terms of the pull-down menus and everything was kind of not right, let's just say. So did a little research, found out that I can change these settings in the NVIDIA control panel. I had to browse to find the Paraview executable and force it to use the NVIDIA graphics card processor. Once I did that, reopen the software, then Paraview, all the menus are correct. So Paraview is a kind of general purpose post-processing tool for scientific results. The reason that I'm using it really is a way to create I can't do it, export a scene that I can read into Blender, ultimately to render a nice image of the CFD results. So let's go ahead and open the results. So let me browse to the directory here. Forget where I'm at. Here. Alright. So the files created by XT are as such. This VTM file is a kind of a pointer XML file that references all the results that were exported. That's the quickest way to get all the results in. Unfortunately, it doesn't give you very much flexibility in terms of the way that you view the results. There's only one node in the tree, and you have to operate on that one node. So what I typically do is just pick off the actual results that I want to get. For instance, the fluid subdomain I may want if I want to create streamlines, the solid subdomain for temperatures, which you could also do fluid surface. Notice there's one file, so one file is created for all the solid fluid interfaces. For this model, if there were other different type of model would have different numbers of files. You also have solid surfaces. Really, what I'm going to be using are these solid subdomain files. And I want you to notice that the way these files are presented in Paraview are these similarly named files are grouped together, because what Paraview is doing is interpreting this as a set of results at different time steps, which is great if it's a transient model. If it was a transient model, I would just load this top node, and then for each time step it would load a different file, which is great. But in my case it's steady state, so what I'm going to do instead is just pick the files individually and bring them in. Okay, so it's brought in all the files. So there's different controls for manipulating the view. Up here, left mouse button is a rotate, the middle wheel, zoom in and out. If I push down on the middle wheel, I'm panning, and then the right mouse button is also zoom. Okay, I have all the results here. Right now it's just displaying as a solid color. I have all these nodes for each individual data set. I can control the visibility with this kind of eyeball icon right here. I can choose what I want to display. In this case, only temperatures are loaded. So I have temperatures. And I want you to notice that this is similar to a kind of a cell fill plot that we would see in XT, but we're going to take care of that. Okay, so let's just go back to solid color. Now I can't click in here and have it pick something in the tree by default, but what I can do is one of these, there it is, select block, would allow me to select a block. Each one of these is a block of data. Alternatively, I can hit B on the keyboard, so I'll hit B, I'll click that, and that's the PCB. So I'm just going to rename it PCB, and then I might want to give it a color. All these steps aren't necessary, but it is might save you some time once you get into Blender. Now I'm also going to select blocks because I need to identify which ones are the heat sinks. So I have 3, 6, and 7. Because you notice that these files are not named conveniently for us. So I'm going to kind of control select these. Paraview has a slick feature where I can group data sets. So I'm going to click that. And now I can do these kind of visibility operations on this. So I could say, let's show the temperature on all those heat sinks at once. Now, the cell fill isn't as apparent now, but I still want to address that. And the way you would address that is by using filters. Everything really is controlled through a filter. And I will search and I will type cell data to point data. Select that. Okay, now it's automatically hidden that previous plot I have, made this active, and I could show temperature of that. So now this is interpolated result in Paraview. Okay, one thing I like to do also is you want to notice that these temperatures are in Kelvin. So I can take care of that with a calculator. So I hit this calculator button and I might give it a title that makes sense to me for this new set of results. And I'm going to create an equation. So it's temperature, and I'm just going to subtract off 273.15. Now for this data set, which is called calculator, I have a new set of results. So I can control the values in degree C now if I want. Okay, so that takes care of that. Some other operations while I'm at it, we could change the background color here if we wanted. This feature right here is to apply changes automatically, which I typically have on, but in some cases you may want to deactivate that. If it's a large operation and you want to make a number of changes before you have it recalculate, you may want to handle that manually. So when you have that off, this apply button is going to be active. Okay, so we'll leave it off for now. I think the next step I'll do is to open that fluid subdomain file. And because I have that activated, once I've loaded it, I need to hit this apply button. Okay, so now we see this big block of data, and we could control its visibility wireframe or just simply an outline. And the goal is here, I just want to create some streamlines. Okay, so let's also interpolate the data. Paraview will store the recent filters you've used so you can access them more quickly. I'll do the cell data to point data. And then I'm going to create, again I have to hit apply. I'm going to then, let's go ahead and make that outline again. I want to create some streamlines. That's called Stream Tracer in Paraview, so I'll click that. By default, it goes the bounding corners of that block of data, which may be okay in some instances, but generally I change that. So we have two choices here, if I could find them. So this is a high resolution line source. You could also do a point source where I could just drag that around with the left mouse button, and I could scale it with the right mouse button. So if we do that, and if we hit apply, well, before I hit apply, if you're using Paraview for the first time, this number of points it's going to seed is 1,000, which is a whole bunch, and it can be a long calculation. So that's why I choose to not have it automatically apply the change. So let's just change this to 50, and I'll hit apply. Right, so we can see those streamlines now. Let me switch the background back to gray. And instead of solid color, we could do velocity. We could color those by velocity. And let's go ahead and have it automatically make the changes again. So as I drag this, it's going to update the streamlines. Okay, so that's one way to do it. What I'm after, though, is this. Instead of this point source, I'm going to go back to high resolution line source, and I'm going to try and remember what settings I have here for the points. Now you can drag these points right along here. Okay. Actually, I want to show you one other thing. So now that I've got this high resolution line source, like I said, the default is this center on bounds, but you can do x-axis, y-axis, or z-axis to kind of get you oriented where you want to be. So I'm going to start with the x-axis, and in the y direction, I am, I think it's, let's try minus 0.2, and for z, I think 0.01. And let's hit apply. So it's calculating right now. Uh-oh, I'm back to 1,000. That's why it's taking so long. Okay, it did it. I want more like 50. And one nice feature about Paraview is that these settings, when I come up here, I see the save button. So I should be able to save these current settings as default. So the next time I create a stream tracer, anytime I'm in Paraview, it's not going to default to 1,000. It will have a 50 there. Okay, so that's useful. Another useful feature is, so this setting is called resolution. So up here at the top, I could just start searching for that setting. Well, this one didn't actually work, but so let's type step. So it'll filter out those settings that aren't related to that search feature. So that's a good feature to have. So anyway, let's leave that. Let me uncheck the show line because it's pretty easy as you're manipulating this view to accidentally drag something. Streamlines are a little bit finicky. It's quite easy to create a streamline that will just run into a solid or kind of terminate where you don't want it to. So you have to kind of play around with the settings in here to get it what you want. But I'm going to proceed. So one thing I like to do once I have the stream tracer is to add some kind of 3D effect to it. So I use tubes. And let me go ahead and have this automatically do this. So I have tubes now, and I can create, or I can affect the radius here of those tubes. So let's maybe go one more here. All right. So we'll go with that. And on these tubes, I'd also like some vectors. So I handle vectors with something that Paraview calls glyphs. So I have that tube selected. I want to add glyphs to it. So it will become a kind of a child of that. Incidentally, you can, if you right click, you could say change the input, and you could select one of these other things. So maybe I want glyphs for that entire domain, right? I don't really want that, but once you create something, you can change its input so that you don't have to completely start over. So what did I have it? I had it on the tube, or we could just do the stream tracer. The next step is, you see these vectors are not pointing the direction that we want. So come down here, we'll change this to velocity and the vectors, the velocity vectors. So now we've got them pointed the right way. We have to kind of scale them down a bit. So maybe go, let's live with that, 0.02 for scale. Instead of coloring them by this so-called glyph scale, let's color them by velocity. Okay, got that. Now the color map here, I can affect the color map down here. I use various ones, but typically I use these days is kind of a blue to red rainbow. And then I also want to do that for the temperatures. There we are. Blue to red rainbow. Apply. And I could hide the legend for these if I want. You can rescale these to a custom range. It'll rescale if it's a transient. You can hit a button to have it rescale for the entire transient duration, which is nice. Or you can rescale to the data range, which is the default here. So this is pretty much what I want to render. It's not perfect, but I would tweak the streamlines so that I have these velocity vectors going all the way through, but for the purpose of this tutorial, we'll keep it as it is. Now I can save this file like that, so I could come back, reopen Paraview, and load this back in. It will load all the data sets and these plots I've created. So the next step is I want to export the scene. We'll export it I'm already in the right directory. The file that I want is this X3D file. So I'll select that option and I'll say OK. So that's all I'm going to show in Paraview right now. So let's jump over to Blender. Okay, we're in Blender now. I just opened it, and when you open it, you get this default cube. To just kind of give you a high-level look at Blender, over here we have a kind of a node tree that has all the objects that are in this model. We have the cube, we have a camera, and we have the lamp. Okay, you can control the view by hitting numbers on your keypad or your keyboard. 1, 3, 7, and 5 is a toggle between perspective and orthographic view. One thing you may need to do if you don't have a number keypad on your keyboard is to go to the user preferences and check this box that says emulate numpad. Okay, that's what I had to do on mine. So to select objects, we right click on them. I'm going to select that, and I'm going to hit X on the keyboard to delete it. And now I will import the X3D file that we created called tutorial. And now we've imported the file. We have a lot of nodes here, most of them related to geometry. We have some lighting that came in with the Paraview X3D file that I would ordinarily delete, but it really has no effect on the ultimate image. The thing I like to do, in addition to the geometry that I get from the X3D file, is Paraview includes a camera. So to switch the camera to that viewpoint, I will select that button and then camera and viewpoint. And the shortcut key for looking through the camera is 0 on your keyboard. So we can see we pretty much got the same view from Paraview into Blender with that viewpoint node. I'll probably want to manipulate that a little bit what I'll need to do is, the easiest way to do it is hit this plus sign and have the camera locked to the view. So then when I rotate, so I'm using the middle mouse button kind of rotating, I can use the wheel to zoom in and out. Also control middle is a zoom like that. Shift middle is a pan. And like I said, right click is to select the different pieces of geometry. To render this image, the steps involved are switch from Blender render to Cycles render, which Cycles render, from what I've read, is much better. It's the newer rendering engine in Blender. So we switch to Cycles render. Other settings I make are to hit this camera button, go to transparent, and then I like just to make the background everything white. Okay. Now, to kind of get a preview of what the image is going to look like rendered, you could go from object mode to maybe that doesn't work. I thought there was a pull down. I always hit Shift Z. So we could see that we do not have any colors yet. So what we need to do is select this, and for the colors of these, let's slide this open over a little bit. It's right here. What I want to tell it is to use nodes. Nodes, applying colors through nodes gives us a lot more flexibility. So I'm going to use nodes. I'm going to drag this down. Blender allows you to create any number of windows inside here for manipulating things. So I've got this upper window area, and the view I want in this is the node editor. Okay, so we see that we have nodes there. What I want to do for this is apply the colors, and the way I do that is I'm going to hit Shift A and input an attribute, and I'm going to connect these two. So rather than being white, I'm going to apply the color through this vector file that was created in that X3D. So let's go to Shift Z so we see the render mode. So right now everything's black, but if I type COL in here, then I get the colors. And we see that over here, the attributes, I have these vertex colors written into this thing called COL. I type it there and I get the colors. The only other change I'm going to make is to right click on this PCB. I can control the visibility over here. I want to make sure I have the PCB selected. Let me get out of this mode. So right click PCB. So this is the PCB. So I can control the visibility. If I don't want something to be rendered, I hit this camera, right? So let's actually not render those vectors. Let's just render the streamlines. Okay. So I have the PCB. I want to use the nodes for that. So I want that PCB to be a little bit glossy. So the way I'm going to do that is Shift A. I'm going to add a shader, a mix shader, and I'm just going to drag it in there. And then I'm going to add a glossy shader. Let's drag those, and I'm going to put it in there. And again, let's do this preview. It's very shiny. When I'm doing glossiness, what I typically like to do is use the same color as the diffuse. Let's make this a little bit darker, but slightly lighter. So anyway, so what that means is I'm just going to use a green. When I try and make things transparent, then there's a transparent there, and then I usually leave that as white. So I mix a color here and a white, and you can control the amount, essentially the weighting of each one, by adjusting the number or just dragging this, right? So we'll just pick one. Now the next step is I come back over here. I want You can control the image size. So by default, it's this size at 50%. So I'll just drag that to 100%. And then we also need to control the number of samples. So this preview, when I hit Shift Z, what we're seeing is a preview. That was 32 samples. If I hit render, it's 128. So I can do render. Let's render the image at 128. And you're going to kind of know that the more samples you take, the higher quality the image is. So we got that. I'm going to hit escape. And so, I've used anywhere from, say, 300 to 500. So let's just use 300. And then I will go to render image. And it's going to, for each processor, it renders a different area in here. You can control the number of processors that it uses. By default, it's going to use everything, but I could fix it and say only use a certain number. So let me just sit here for a minute while this renders, and we'll take a quick look at the image and be on our way. Okay, as this is finishing up, I just want to say there's a whole lot of features in Blender that we didn't talk about. There's a lot of lighting controls. You can position lighting. With these shaders, you can do all sorts of things. So this is really, like I think I said earlier, this is a point A to a reasonable point B, really capturing results from, in this case, XT through a Paraview file, creating plots in Paraview, and then exporting that as an X3D file to bring into Blender to render. So once you've rendered the image, then you could come down here and just say save as image, and give it a name, and then save as image, and then you can escape that and you can control the view some more and render some more images. So that is a brief introduction into XT to Paraview onto Blender. Thank you.